Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so check out Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. Go to pythonpodcast.com/linode today to get a $20 credit and launch a new server in under a minute. And to keep track of how your team is progressing on building new features and squashing bugs, you need a project management system designed by software engineers for software engineers. Clubhouse lets you craft a workflow that fits your style, including per-team tasks, cross-project epics, a large suite of pre-built integrations, and a simple API for crafting your own. Podcast.init listeners get 2 months free on any plan by going to pythonpodcast.com/clubhouse today and signing up for a free trial. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the newsletter, and read the show notes. And keep the conversation going at pythonpodcast.com/chat. Registration for PyCon US, the largest annual gathering across the community, is open now, so don't forget to get your ticket and I'll see you there. Your host as usual is Tobias Macey, and today I'm interviewing Syrus Akbary about Graphene, a Python library for building your APIs with GraphQL. So Syrus, could you start by introducing yourself?
Yeah, hello everyone, I'm Syrus Akbary. I've been working in Python or in startups for about 10 years, and right now I'm trying to go through the entrepreneurship path, and I'm trying to build a company.
And do you remember how you first got introduced to Python?
So I think it was 10 years ago. I was in college, and actually I already have programming experience, which was with PHP. I guess we all have a starting point. When I discovered Python, I saw it matched very well with my train of thought. So I just fall in love with it, and since then I've been developing in Python.
And so can you start by discussing a bit about what GraphQL is and the benefit that it provides versus a REST-based API that people might be more familiar with?
Yeah, sure. So GraphQL is a specification that helps us on the task of creating APIs much easier and more reliably. So how it compares, or what is the benefit of GraphQL versus a REST-based API? It's basically because GraphQL help us on creating or having a type-safe API, and then it help us to retrieve much more data at one request rather than REST API that in general we have to do multiple HTTP requests for fetching all the data we need. So mainly I will say GraphQL helps on implementing your API from a domain-driven architecture rather than how things are modeled on your database. And that actually helps on making APIs that makes our clients happier. That means it's easier to query and to use.
Another area of work that has happened over the past couple of years is in putting forth specifications such as OpenAPI and RAML as a way to try and standardize the way that REST APIs are built. So I'm wondering if you can discuss a bit about how GraphQL compares to those efforts and whether you think those are still useful in comparison to what's possible with GraphQL.
So I think actually both OpenAPI or Swagger and RAML are a really great step forward for REST APIs, as it provides a description format for it, and actually it let us know how we can do HTTP requests for REST APIs and what kind of data we can expect to get back. However, I think there are a few reasons that put GraphQL at a better point or as a better suit solution than OpenAPI. And these reasons are first that the types are built into the specification. Therefore, you cannot really escape from typing even if you want. So if your GraphQL type is expecting to have a field that is returning a string, you cannot suddenly return an object or a number or things like that. And with Swagger or OpenAPI, it really depends on how you implement it. So even if you document it really well, you can still escape from that. Other advantage or other reason for using GraphQL instead of REST is because it provides a nested fetching mechanism. What this means is you can actually fetch nested data. So if you want to fetch a user, and from a user you want to fetch their photos, for example, in REST you will this will involve like doing tons of HTTP requests, one for the people model or the users model, other for the photos model, and so on. And with GraphQL, you only have to like do one HTTP request and you retrieve all data at once. So these two are kind of like the big factors. Over these two, there is another one that I think it's quite important, is that the fact that simplifies incredibly the effort required in the clients to integrate the data returned from GraphQL into their data flow. That's because like you stop the clients have to stop worrying about like how to glue or stitch data together on the client side, and it's done automatically with GraphQL clients.
And I know that when GraphQL was first made public, there was a lot of excitement in the JavaScript community because it made their lives easier in terms of consuming APIs. But on the backend development side, it increased the complexity to a degree because of the amount of effort needed to be able to effectively respond to these GraphQL requests where there is potentially nesting and recursion. I was wondering if you can discuss a bit about how a GraphQL API is implemented and how Graphene simplifies that process overall for somebody who's trying to create an interface that is conformant to the specification.
So basically, like GraphQL with Graphene is easy to build, and the main reason is because like Graphene already provides you with the types and the structures that like GraphQL needs. So the only thing that you need to do from the Python side is just create like Python classes that like inherit from a Graphene object type, and from there like you will need to implement resolvers, which specifies like how each field is going to be resolved, or like how each field is going to return data to the GraphQL endpoint. And from that, like you stop worrying about like how Graphene or GraphQL is doing all the things, because it's actually like a little like it's handled everything by the framework. So you like as a developer creating a GraphQL API, you don't worry about like how the nesting mechanism is being implemented or anything like that. You just worry about like how to create your types and how to retrieve fields within your types, and that's it. And then like Graphene provides all the structure and all the implementation regarding GraphQL to assure that like this matches the GraphQL specification.
And can you discuss a bit about what it is that Graphene is doing behind the scenes and how it's implemented in terms of the actual library itself?
So first, like what Graphene is doing is first analyzes the query that the client is making. So it runs a parser, it gets like all the fields that like it's trying to get, and knowing like how is the schema structured, it validates this query against the schema. So for example, if we are trying to query a type that doesn't exist or a field in a type that doesn't exist, Graphene will complain about it. So you will see an error and the query will not even get executed. So this is the first step, validation of syntactically first the validation of the query, then like the validation against the schema. That means like we are able to run queries that matches our structure. And the last one is if these two passes is running the query. And for running the query, like first we take a look into like all the fields that you are trying to request, and or the client is trying to request, and then like we try to look up all the types from GraphQL, and we try to go into like how you implemented them, and we call the resolvers that you created. So this is more or less like how everything matches. And once Graphene basically like retrieves all the data, it returns it back to the client. So it gets the client gets data in the shape they expect.
And how has the implementation of Graphene changed since you first began working on it?
Actually, it changed a lot. At the beginning, just because I didn't have like enough context on GraphQL and how everything like works, I focused a lot on like how to create an API that was very easy to use, and that was kind of like my main goal. However, the implementation, I have to say, was not very good. Like was bad. But after working on it like for a few months, I got a better idea of like how it should be implemented, and I completely refactored from scratch. That means like starting from scratch, like removing all code and creating a new code base. But thanks to the API, basically it still match how I think like a GraphQL should be created and used. Like basically the implications for the developers were almost none. Basically, like they were able to still use Graphene with the exactly same syntax. And then about like another year ago, I got like much better context into like how I should make the internals of Graphene. And with that context, I decided to refactor again from scratch, which I did, and yeah, it was we have like some small breaking changes, but overall, like the API and the way you create types like is almost the same as the first version of Graphene. So yeah, I like my recommendation here, like for whoever is creating like a framework that is intended to use by like more companies or more people, is like focus on the API first, make as many tests as you can, especially on the less on the internals and more on the interface that you are serving developers. And then once you have that, it's very easy to refactor or to improve things as you gain context on the project.
Can you talk a bit about the motivation that you had for creating Graphene in the first place and some of the other libraries that you have built to accompany it, particularly the JavaScript implementation?
Yes, sure. First, it was super funny because I think it was about 3 years ago. Facebook invited me to their offices. They were trying to hire me, and they were doing like a private show showing their new baby that they were gonna expose to the world. When I saw it, I saw certain potential, but I personally thought like was only gonna be useful for Facebook and not outside. But like this was kind of like just from first sight. And after a week, the Facebook released first implementation. And with that, I got the opportunity to play with it. I also like know JavaScript, and I'm like super used to the front end stack. So I started playing with it, and I saw like an enormous potential because I have been like building APIs or dealing with APIs for more than like 6 years when I started at that moment. And I saw like a lot of potential. And at the moment, there was no framework for using GraphQL in Python, and I saw in that like a incredibly great opportunity to build something that can make an impact in the way we develop APIs.
I think you probably started working on this shortly after I gave up on trying to implement a GraphQL API because that was around the time frame when, as you said, it first came out publicly, and I was in the process of greenfielding a new API-oriented Flask application, but trying to figure out how to make it compliant with GraphQL at that early stage was a bit bigger of a lift than I wanted to deal with. So I ended up just going with a traditional REST interface.
Completely. Actually, like at the beginning, like the process that I got to make Graphene kind of like successful is by like porting the JavaScript version completely into Python. This required, I think, was like more or less a month of effort. But with that, like we assured that like our implementation was like 100% compliant with the spec. And like once we have that, like was much easier to start building on top of that. But yeah, like actually, like even the fact of porting, which is less is not as hard as creating it from scratch, because like you already have a base that you can start with. Even the start of porting the code like was not super easy. So yeah, I completely understand. Like starting with GraphQL like few years ago was not really that easy.
And in addition to the base Graphene library, I know that you've also built some integrations for SQL Alchemy and Django for tying into its ORM to simplify the creation of APIs that interface with SQL databases. So I'm wondering if you can talk through a bit of the integration involved there and some of the difficulties of getting these SQL libraries to produce data structures that are easily represented in the GraphQL format.
So actually, like was less challenging than I thought. First on Django and then on SQL Alchemy, I built like the integrations of them into Graphene because I thought like it was gonna be a very good point for making like developers start using GraphQL in Python. Basically, if you make a easier path for them to build GraphQL APIs, so they don't have to worry about like how to map from SQL Alchemy models or Django models into GraphQL, then like that's a win for them. and it will be a win for Graphene because like they will use the library. And like what was challenging about like making integrations from Graphene or from SQL Alchemy or Django or the Django models to Graphene was actually just a little bit of introspection to see like how we can like look up the types that SQL Alchemy is providing, and how we can see like what are all the columns that like these models have, or what are all the fields that like these models have, and try to map them like one to one to Graphene. But like actually, I will say like the integration, it took like, for SQL Alchemy, the first integration I would say took like 4 days or something like that. So it was not really that hard. It's like at the end, like we are dealing with like Python types with Python objects, and it's super easy to introspect them and to go from one to the other. So actually, like Graphene at the end, rather than transforming your SQL Alchemy instances, I will say, rather than transforming it into GraphQL types, what it's doing is reusing your same types and just kind of like matching the output of these types to like what the GraphQL is querying.
And in terms of ensuring that your implementation in Graphene is fully compliant with the GraphQL specification, is there any sort of publicly available test case that you can run it through for validation?
Yes, actually, like tests are built into Scratch into both Graphene and GraphQL Core, which is like the library that like powers Graphene. I think that right now there is about like 98% or 99% of like test coverage. That means like almost all lines of code that you will be using within Graphene are tested. And with that, like we just started looking into like all the test cases that the GraphQL main implementation in JavaScript had, and try to replicate them in Python. So this way we can assure like 100% to be 100% spec compliant. So yeah, testing is like having testing in general is like super useful.
And what have you found to be some of the most complex or confusing aspects of building GraphQL APIs, both with and without Graphene?
So first, I think like there is, because of like with GraphQL, you have to model your API into a way that like your clients, you have to know like how your clients are gonna query this data, and I think that's a main aspect into like how you build a GraphQL API. First, you have to understand like how your data should be queried. So first, you are not serving models per se. You are serving kind of like connections and how these models relation between each other. And with that, like you have to spend like fair amount of time trying to analyze like how your clients are will be using your data in a very easy way. And that means kind of like introspecting, using your application, if you have like a, if your company is serving a mobile application or your desktop app, and seeing like for each page how the data is used and served. You start analyzing that the scenarios, and with that, like you will start having an idea of how you should structure your schema and the relation between your types. Even in general, like this relation like maps almost one to one with the how you shape things in the database. In some cases, it doesn't. So it's very good that you are aware of all these cases. I will say like these are the first steps of involved in building a GraphQL API. But once you have a clear idea of like how should be the structure of your GraphQL schema, then it's super easy to implement it. It's just like create your Python objects, build your resolvers, or reuse implementations that already exist, and that's it.
And I know that GraphQL, because of the fact that it's agnostic to how the data is retrieved on the serving side, it's possible to combine multiple data sources together in a given response. And so I'm wondering how you would structure that in Graphene as far as being able to retrieve from either multiple databases or federate the query out to maybe different microservices.
Yeah. So basically, like the first aspect is everything is kind of like monolithic, and we have like one code base that like is serving all our GraphQL endpoints. From that point of view, we can use like almost anything that we want. We can use Django models with SQL Alchemy models, and both like talking together. Or we can use like Redis database and then like Django or SQL Alchemy, and we can mix them like in the way we want. Really, like it doesn't matter. We just have to know like how to relation them between the functions. So basically, like how to retrieve like certain Redis object from a Django object or a Redis relation from a Django object or things like that. But in general, like how to do it like within the same code base is super easy. What it gets more challenging is actually like when you have like multiple microservices that are completely isolated between each other regarding database and regarding code base. And with that, actually, like one of the things that we are working with Graphene is providing schema stitching, and this actually means like being able to match or to glue together different GraphQL APIs into only one. So at the end, like there is only one GraphQL API that is being queried by the client, which I think is super important.
And I know that one of the optimizations that GraphQL provides is primarily felt on the client side of not having to have multiple round trips over HTTP. But because of the fact that you might be fetching data from multiple different systems in the back end, it in some ways just pushes that same complexity further down while shortening the overall round trips. But because of the fact that one API request to a GraphQL endpoint may end up being more complex to render, it can reduce the overall responsiveness and throughput of the serving layer. So I'm wondering if you have encountered any situations where that's become a problem and any strategies that you have established to mitigate it.
Sure. Actually, like I will say at the end, all the data that we need to serve, if it's for creating websites or application, it depends on like how we design the pages. So basically, for application or desktop app is trying to serve like a lot of data. That means like it's trying to serve a user and the name of a user, and then like 100 photos, and then from each photo like 10, the first 10 comments. Then like no matter what, you will need to request or get all this content, right? So at the end, you will not end saving any time using REST over GraphQL. Neither the other way. The only thing is with GraphQL, rather than doing like 100 requests, you will do only one. So you will save latency. Another interesting step into like how GraphQL is even faster than REST in these cases is because there is one strategy called data loading. And with data loader, actually, like what you can do is cache things if you already like serve them. So for example, if you are requesting a photo that have a comment on it, and this photo belongs to user A and have a comment of user A and user B, with REST, for example, you will do like 3 requests, one for user A, 13 fields, then like you will retrieve the photo, and then you will do another request for user A and user B again. With GraphQL, all this is solved with data loader. But not just that. At the same time that you are requesting, for example, 3 same types at the same time, like you're requesting 3 different users at the same time. With the data loader strategy, what you can assure is rather than doing like three SQL queries, for example, under hood, you're only doing one. So all these strategies are actually like much harder to solve from a purely REST point of view.
And what are some of the capabilities that are unique to GraphQL APIs that wouldn't be possible when using a REST interface?
So unique capabilities, there are few. One is like everything is typed, which I think is super good, especially if you are not in a typed language. Like Python is not typed right now. With Python 3, we have annotations, which I think they are a great step forward. But in general, like it adds types on top of our system, and especially non-type systems like gets a big benefit from this. The second one is you have introspection into your GraphQL schema. And what that means is the clients can know like what is the structure of the API, and these have like a lot of benefits. One of these benefits is the clients can auto generate very easily or look at the documentation of the types super easily. And the other one, which I think is a great tool, is Graphical. Graphical is an interface for querying GraphQL APIs that actually let us introspect these GraphQL APIs while we are typing, and it have auto-completion of the fields. We can see like what we can query within like a type, and we can see also like what is all this documentation for the types that we are querying. So at the end, like all these things, introspection, type safety, and soundiness, it helped us a lot into like querying and creating our GraphQL APIs.
And are there any particularly interesting or useful or unexpected lessons that you have found to be particularly valuable in the process of building Graphene and using it to create GraphQL APIs?
First one is community is essential. I do think like getting in touch or getting feedback as soon as possible from people using your framework is essential to make it grow, and actually helps a lot adoption and users using your library like know that like you are aware of their thoughts and how they think like the library should evolve. So I think that's one of the things that I learned from Graphene. The other thing is like testing is super, super, super important. It actually assures for big companies or companies in any size that they can use Graphene reliably. The other thing that I thought I could actually might be better if I thought about this like when I started is like how can I make this a sustainable project? Because right now like over time it become a little bit harder to know like how now companies that are using Graphene, which are about like 5,000 companies in the world, how they can help the ecosystem to grow in a way that is sustainable and it doesn't depend into only one actor, but multiple.
And on the sustainability topic, it seems that one of the approaches you've taken is to build the Quiver project to help optimize the serving of GraphQL APIs built with Graphene. So, can you discuss a bit about what the Quiver project is and how it fits in with the other Graphene projects and how it fits in with your strategies for ensuring that you can continue to support your development efforts on Graphene?
Sure. So Quiver was the first commercial solution based on Graphene. What it is a step up on the GraphQL engine that is focused on optimizing the overhead of the GraphQL engine. So it actually can run at almost native performance. So that's kind of like the first goal of Quiver. Right now is being used by two companies that are actually like paying for it. And we can talk a little bit later like what Quiver is doing like under the hood to optimize the API. But basically, like with Quiver, I'm helping to sustain the Graphene ecosystem and GraphQL in Python in general. And it's a way that actually like big companies can start paying or offering support. So basically, like small companies can also take advantage of the ecosystem.
Yeah, if you could dig a bit further into some of the strategies that you're using for optimizing the API serving in Quiver, I think that would be interesting.
One of the things that you have to know is I've been like super interested in template engines for like a lot of years. And I think it was 8 years ago, I built like a template engine, which was called PyJade, was for generating HTML code more or less more easily. And with that, I discovered basically like what kind of templates there are and so on. And I discovered there were two kind of templates, the one that were fast and the ones that were slow. So for example, if you take a look into the Django template engine and the Jinja one, like both have a very similar syntax, right? But like Jinja performs from 10 to 20 times faster. How they do that? They actually like compile, like Jinja itself compiles the template to Python code to remove completely the overhead of a template engine. So running render on a Jinja template is almost the same as calling a function that returns a string. And with Django, actually, you have to run through the lexer, parser, and all this stuff. So there is a lot of overhead. Having this experience, I started thinking into like how we can start optimizing the the GraphQL engine, because for some cases, for example, there were some companies that were returning like 100,000 objects with a lot of fields in each, and it was taking like few seconds, while it should take like 100 milliseconds or something like that, basically for just kind of like the base JSON serializer. So I started thinking like what I can do to improve the speed. And based on this experience, on the template experience, I started researching with the idea of compiling these GraphQL queries to Python code to remove completely the overhead of a GraphQL engine. So basically, with Quiver, that means that running GraphQL queries is the same as building your own endpoints at hand, doing all the smart fetching mechanisms that like GraphQL is doing under the hood, but without the overhead of running the GraphQL framework. So basically, with Quiver, you can see more or less a speed up of 5 to 20 times faster, if of course you don't count the I/O in your API.
And you're providing that as a managed service for people who need that performance improvement. So I'm wondering if you can discuss a bit how successful that is in terms of enabling you to spend a significant amount of time focusing on Graphene and building its ecosystem.
Yeah, so thanks for like that question, because it's been like a little bit challenging to make it work, especially at the beginning. But like a lot of companies show interest. It was hard to know basically like what kind of pricing should I put, how I'm like super involved into like having all this open source, but at the same time I'm worried of like open sourcing something and then like not being able to sustain like this project or any other. So what I decided to do is kind of like offer this as a kind of like paid solution. And so far, like few companies are paying for it. It's not doesn't help me like to reach like even like 20% of my needs of like living in San Francisco, which I don't know if you know, but it's super expensive. So it doesn't cover like most of the needs, but at the same time, I think like we just need a little bit more of time to get like more companies or big companies to use it. I mean, I'm talking like with really big companies that they are interested in trying Quiver, and for example, they are like performing about like 1,000 to 2,000 queries per second. And in these cases, like it's super like they can get a lot of benefit of using Quiver. But like my goal eventually is actually like open source it, but only once I'm able to sustain myself, and basically once I can verify that like big companies are up for sustaining this project.
Yeah. One licensing model that might be interesting to explore down the road is one of the ones where the source code at a particular release reverts to open source after a period of something like 2 months, which allows people to take advantage of the project on their own terms while still providing incentive for someone to pay so that they can stay up to date with the latest releases and latest improvements while still having that option.
I think that's a quite interesting option. Right now, for example, like I'm trying this to grow naturally. Like I don't want to push any companies to use it or to pay for it. Right now, other strategy that I'm following is I created a Patreon page just so people that are using Graphene or companies that are using Graphene and wants to sustain the project, they can do it like without like getting anything in exchange. I mean, in general, like getting like probably like more visibility, their logo on the Graphene page, and helping to sustain the project. But like with a specific term of this is for paying for Quiver or anything is in specific, it's just gonna be like this is for support the project and making sure like it's sustained over time. So this is something that I'm still playing on, but I'm not sure. I'm not sure like how this will end and what will be the end path for like making Graphene kind of like a fully sustained and supported project. However, I'm all in to like sustaining it myself while I can.
And in terms of someone who is interested in building a GraphQL API on top of Graphene, can you just talk through the workflow of going from either an existing or a greenfield application through to having an API available that is implemented on top of Graphene and serves as a GraphQL endpoint?
Yes. First, we'll need to know like basically like in which server framework are you using? Like, are you using Django? Are you using Flask? Are you using Async.io or Sonic? Like, basically, what kind of like server framework are you using? This will help you to get the integration of Graphene in that framework much easier, so you don't need to write like the implementation by hand. And we have like implementations in almost all almost all server frameworks, so it should be easy for you to integrate that side. And then like you will it will be useful to know like basically what kind of data system are you using, if you are using any ORM, and looking at integrations of Graphene into your ORM. And just by following the documentation and see kind of like how you can like plug your own model to a Graphene or GraphQL model, That should be like super easy. So basically, like, you start downloading Graphene, you start downloading the Graphene integration within your server framework, then you download the Graphene integration with your ORM framework if you have any, and if not, you can do it by hand, the integration, and then you just run your server, and that's it. Like in general, like starting with a GraphQL server or plugging a GraphQL server between an existing Python server is super easy. It should take like at most 5 minutes.
And once you have the schema defined, it also mentions that you can define the queries that are available. So I'm wondering if it's possible for a given client to be able to generate queries that don't specifically match what's defined on the server end, or if the queries that get defined in Graphene are the only ways that are available for interacting with the API.
Yes. So first, when you query, the first thing that happens when you do a GraphQL query is we validate the query. We first check that this is syntactically valid. That means like it matches the structure of a GraphQL query. If this doesn't happen, if that's not the case, then like we stop their execution and we throw an error. If for whatever reason it's a valid GraphQL, syntactically valid GraphQL query, then we check if the query can be run against our schema. Basically, if we are able to query the fields that are exposed within GraphQL. If for whatever reason you're trying to query things that are not exposed, it will also throw an error. So you will not be able to query more than it's exposed to GraphQL. So that's in the case like you are running GraphQL queries that like matches your schema. Because in the case they don't match, then the request stops. But in the case they match your schema, let's say like you have a type which it have a field that takes a lot to resolve. For whatever reason, resolving this field is super expensive. Let's say it does like a super complex SQL query under a hood, and you want to limit basically like how many times you can do it or things like that. There are a lot of mechanisms in Graphene that you can implement to make sure like first like things are not queried much more than they should. You can add like defense mechanisms there, but other things that like in general other companies does is they define a set of all valid GraphQL queries, and if you try to go outside of these valid GraphQL queries, it will throw an error. So in general, even if the queries are dynamic, they are dynamic in development mode. In production mode, they are static, and you cannot go over like a statically defined set of queries. So if you go or like if you try to do something dangerous, trying to run like any other query, it will also like throw an error. So in this sense, there are like a lot of mechanisms that you can do to stop. Or even like you can implement a middleware and check like how many fields is a user like querying, and if it's more than they should, you can just stop right away.
What are some of the most interesting or surprising ways that you've seen Graphene and GraphQL used?
So one of the most surprising is, I would say most interesting is like using GraphQL or Graphene like to actually like scrape HTML data. I think that was kind of like super interesting use case. It was not very surprising because actually I created it, but like it was a funny way to play with GraphQL and show to people that actually like it can be used for some more things other than like fetching data from databases. In the case of scraping data is something that like it was not very common to see before. But like there are a lot of other use cases that it was a surprise to see. For example, like at the beginning, Graphene was meant to, or GraphQL was meant to for a server to client communication. That means like from a server to either a mobile app or to a desktop app or like any kind of client that you can control. But it was never thought to be used at the beginning for server to server communication. That means like you have a microservice. This microservice serves a GraphQL API, and then you have other microservice who wants to consume this GraphQL API. So for that case, there are certain scenarios that were not covered. For example, the case of like fetching 100,000 fields or 100,000 object types. And this at the beginning was a little bad surprise because I realized I have to make Graphene much more performant to make it happen. But then like once we went over like the cases, like we basically like down the time from, I don't know, 10x, I think it was, or something like that. So yeah, these have been like some interesting uses of Graphene for sure.
I particularly like your mention of using Graphene to serve web scraped data via the GraphQL API, because it just showcases the fact that the resolvers for the given schema are just an arbitrary Python function. So as you mentioned, it doesn't necessarily have to retrieve data from a database. It can do
That's right.
arbitrary API requests of its own, or it can, as you said, go out and scrape a website, or just anything that you can do programmatically with Python, you can potentially return as a data object within that GraphQL API. So it helps expand the way that people perceive what's possible.
Yeah, at the end, like if you are serving that data, for sure, and this data have relations between it, for sure you can use GraphQL in it. There are some challenging cases. For example, if you want to do things that look like joins or aggregations in GraphQL, I will say these are like challenging cases to do it properly in GraphQL. But almost all other cases, that means like fetching data and relations between data, you will see like in GraphQL and Graphene like a very good opportunity to play with GraphQL.
And what are some of the cases where it would make more sense to use REST or some other more commonly used interface instead of GraphQL?
So I think GraphQL is very useful when you are in control of the clients that are querying your data. However, like sometimes you are not in control of that client. That means like for whatever reason, your company is serving APIs that other companies are trying to consume. In this case, like it depends if these other companies want to use GraphQL or not. And in some cases, they still want to go through REST. So for that scenario, probably like you are still good with REST because you cannot change your clients. But whenever your company it dominates or can dictate like how the clients behave or how the clients are built, then like GraphQL is a very interesting scenario. Because I think like one of the most useful things about it is you can create GraphQL APIs at a much faster pace, or APIs in general at a much faster pace. And not just that, but like the front end incredibly gets a benefit from that, in the sense of like their developing time or things like that. So for me, the only case when like I will use REST is if you have like no control over your clients and your clients want to still use REST, then you're tied. Otherwise, GraphQL should be like a good option to research.
And one of the nice things too about the fact that GraphQL is served up from a single endpoint is that it makes it easier to progressively add support for GraphQL to an existing application that already uses REST. So if you're using something like the Django REST framework, but you want to support GraphQL as well, you can do it in parallel, and the client can decide which interface they want to use until the entirety of the functionality has been encapsulated in that GraphQL endpoint. And you can then, in theory at least, depending on how the clients are distributed, turn off that REST endpoint.
Yeah, completely. Actually, like in Graphene, we have all as well like integration with Django REST framework. So you can map your Django REST framework models to GraphQL types automatically, which I think is super powerful. But one of the interesting cases for companies that they still need to have to serve REST endpoints, but they want to research into GraphQL, is building your REST endpoints on top of GraphQL queries. So basically, like for the client, it will still look like a REST endpoint, but under the hood, this REST endpoint will do a GraphQL query, like in your implementation side. So this way you are still kind of like using GraphQL for building your API structure, but this way you provide a easy wrapper for clients that still depend on REST, which I think is a super interesting use case.
Yeah, that's pretty funny. Have sort of building the GraphQL API alongside and then shunting it underneath as you move the existing REST endpoints over to just use the GraphQL that you built.
Yeah, that's I think there is a good opportunity for that, and I know like few people are working on like making that to happen with Graphene. We just need a little bit more time to do it in an automatic way, but in general it should be like super easy even if you do it by hand.
And for anybody who's interested in learning more about the GraphQL specification and the ecosystem that's being created around it, what are some references that you would recommend?
So first, the GraphQL.org website it's great. Like you have a lot of resources, and it describes like very well the different types that we have in our GraphQL schema. So, so we can see like what is an object type, what is an interface, what is an union, what is a field within a type, and all these kind of like relations. So that's useful. Apart from this website, which have a little bit more of documentation on the GraphQL JavaScript side, we have How to GraphQL, which is a website that I have tutorials for using GraphQL in almost any language, including Python. And apart from that, in the Graphene Python itself website, we have documentation and good tutorials to get started on GraphQL and Graphene.
And what do you have planned for the future of the Graphene libraries and ecosystem?
So it's very interesting, like what we have planned ahead. One of the first things that I thought is actually like moving Graphene to other languages. So they are available, for example, in JavaScript or Ruby, basically with the same kind of like syntax of creating GraphQL types. However, like there is a little bit of it's not easy to reach a lot of like different languages. Right now, especially for Graphene in Python, we are working on getting up to date with the latest spec. Right now, one of the most challenging things that we did at Graphene is actually like make it work same code base, either if you are using Python 2 or Python 3. But this brought some downsides. For example, like if we do that, we can assure like that you can use async IO, but like we have to do a lot of things under the hood to make it work as well with other async frameworks like Gevent or something like that. One of the efforts that we are doing is moving the GraphQL core library, which is like what powers Graphene, up to date to like Python 3 with the type annotations and all this stuff. Other thing that I think is super interesting is being able to generate your GraphQL types from Python objects that are annotated. So you just need to create like a normal Python object that is annotated, like have annotations, and it's saying like, okay, this field is a string, or this field is an integer, or this field is it's a relation to other object. So one interesting use case that we are researching on is regenerating these GraphQL types from annotated types in GraphQL. And this is more in the short term. From now to 2 months, like we'll get like these things ready. In the long term, though, just looking into like how we can make like Graphene to be available in more languages. I'm looking into universal GraphQL, which is kind of like a universal way for defining like GraphQL schemas that can be actually available in any language or can be used in any language. But this is more kind of like long-term planning and have to do with other things that are less close, are not as close with Python, like WebAssembly, but I think have a lot of potential to make Python shine even more.
Yeah, as I was reading through the documentation and looking at the schema definitions, I was thinking how it would be interesting to see how that would work in terms of being able to auto-generate the schema from a simple decorator on the data classes that got introduced in Python 3.7.
Yes, actually, I'm super interested. I love the data classes syntax. I think it's super smart. And like actually, the thing that we are researching into like generating GraphQL types from annotated types is completely based on the data classes from Python 3.7. Um, it will be great. I mean, I don't remember like what's the URL of the issue where we are tracking this, but like if you go to the Graphene repo and you search for type annotations, I think you will find there the issue. And you can see like basically what is our research, but it goes over a very similar syntax of using data classes, which I personally think they are great.
And are there any other aspects of GraphQL and its ecosystem or the work that you're doing with Graphene and its various libraries that you think we should discuss further before we close out the show?
I mean, in general, I will love that like people will start like playing more with Python 3, like kind of like getting more involved in like the Python script process of Graphene, and how we can make it like more like type safe, and with static annotations with MyPy, and how we can make it like a tighter integration with async IO and all this stuff. But other than that, I think like we cover like most of the Graphene stuff, or GraphQL stuff in Python.
And for anyone who wants to follow the work that you're up to and get in touch, I'll have you add your preferred contact information to the show notes. And so with that, I'm going to move us into the picks. And this week, I'm going to choose the Audible service. It's so when we go on long car trips, it's great having audiobooks to listen to because it keeps everybody happy and engaged. So that's been very valuable. And sometimes waiting for certain books to be available on hold at the local library ended up taking a bit too long. So having the Audible subscription is great for being able to just get easy access to the specific book that you want, and it's a fairly reasonable cost. So that's been it's been a useful subscription to have for the past few months. And so with that, I'll pass it to you, Syrus. Do you have any picks this week?
Yes, I have the. Okay, I'm super biased. I have the pick of the Patreon website for Graphene. It's gonna help. It's gonna help the ecosystem move forward, and basically like everyone that is using GraphQL, like be sure that like that the project is sustained and like is moving at a pace that like all we need. But yeah, like jokes aside, I will recommend like two things. One is like for people taking a look on WebAssembly. I think it's the future of computation in a lot of ways, and I'm super excited about it. It's not only browser side. That's one of the picks that I wanted to do, and I have other one in mind that I just forgot. But yeah, let's say WebAssembly, and let's see if people are curious about it and ask me any questions.
Well, I appreciate you taking the time today to discuss the work that you've put into Graphene. It's definitely great to see something of that level of polish available for Python developers to leverage some of the new interfaces and new practices in the technology space. So thank you for that, and I hope you enjoy the rest of your day.
Thank you. Thank you for inviting me, Tobias, and I hope you enjoy the rest of the day too, and hope to stay in touch.